Hey everyone, so I'm Craig, currently in New Zealand, but I'm usually based in Stockholm. I'm an engineer at Spotify. You can find me on the internet, you find all my stuff everywhere you want. But today, I'm going to tell you all a story. And it goes a little bit like this. Chapter 1. A very helpful reindeer. It was nearing the end of winter in the kingdom of Arendelle. Sven the reindeer was feeling very, very productive. He had been helping his best friend, Kristoff, the royal ice master. Kristoff and Sven had been friends since they were very little, and it was their job to make sure that Arendelle always had enough ice. Sven was always looking for ways to work smarter, and he could always count on help from Olaf the snowman. Less work means more time for adventures. And Sven and Olaf love adventures. Chapter 2. Sven's most magical idea. Sven and Olaf had two other special friends in the kingdom. Princess Anna and Queen Elsa. Anna is the brave, tenacious princess of Arendelle, and Queen Elsa is her big sister. Queen Elsa had amazing powers. She could sense the water molecules around her, transform those water molecules into ice, and control that ice however she liked. Sven would never forget the day that Elsa explained her magic. "I'm going to let you in on my little secret," Elsa began. "You may have heard that any sufficiently advanced technology is indistinguishable from magic. But actually, it's the other way around. Any sufficiently incredible magic is actually technology. And the technology that makes my snow magic work is called TypeScript." Sven already knew TypeScript from his work running the website for the local sauna, and he couldn't wait to learn more. Sven and Olaf wanted to use Elsa's ice magic to make Kristoff's life a bit easier. And they'd figured out the perfect plan. They were so excited to share it with Anna and Elsa. Snort. Sven snorted. Anna was thrilled. "That's a great idea, Sven. You can take Elsa's TypeScript ice magic and create a library that anyone can use. This is going to save so much time." Elsa couldn't wait to help. "Let's do this," she said. "Anna and I will help you learn about TypeScript." Chapter 3. You can't freeze everything. Sven and Olaf got straight to work on their new library. They designed their ideal API. It had just two functions, freeze and thaw. You could take a thing, freeze it, and then thaw it to get it back in the original state. They started building out the functionality. The freeze function would be a nice wrapper around Elsa's ice magic, which Elsa would help write down later. "This is great. We're amazing," Olaf exclaimed. "Anna and Elsa, what do you think?" "This is really good. Great work," said Anna. "But do you want to make it even better?" asked Elsa. "Let's talk about developer experience. What would happen if a user imported some magic fire and then tried to freeze it? You and I know that you can't freeze magic fire, but our users may not know that. If they were to try to freeze magic fire, there would be serious consequences, but our library allows it. It's our job as library authors to save our users from these kinds of traps. Right now, we're using the any type. But that's okay. It's not super easy to see how best to type this code. We want to be able to freeze almost any input. But right now, the code says that you can freeze absolutely anything." Grunt. Sven grunted. "That's right, Sven," Anna replied. "We need to find some way to limit the kind of objects that can be frozen, so that no one can freeze something that is unfreezable." One thing we could do is catch the problem at runtime, Elsa suggested. We could check for the presence of the unfreezable property and then throw an error. But we can do a bit better than that. It would be better for the library user to know about the issue before they run the code. And that's where TypeScript can help. Anna, why don't you explain? TypeScript has lots of different types, began Anna. There are all the primitive types like Boolean and string. There's all the built-in types like array and date. And then there's all the custom user-defined types. These types all form the TypeScript type system. One way to think about this is like a Venn diagram. You have all of these different types, which each do their own thing. But they're all contained within a default type, which is called any. The any type is what is called the top type of a type system. It is a supertype of all other types. It's a type for which all values are valid. Using the any type tells TypeScript that any value can be assigned to the variable. So when TypeScript sees an any, it basically stops type checking from that point on. The any type makes our code very flexible, but it can be a bit dangerous. Here, if the toFreeze input is undefined, our code will break, but the compiler doesn't complain. So we want our library to be flexible, but without the danger, asked Olaf. Is that even possible? Yes, replied Anna. TypeScript gives us another tool for this. We can use the unknown type. Let's look at the Venn diagram again. We have the same Venn diagram before with all the specific types in the middle and any as the supertype of all of these types. But we can add another new friend in the middle called unknown. The unknown type is also a top type of the type system. It's also a supertype of all other types, and all values are also valid. But it behaves a little bit differently. If we replace the any with unknown, we now get a compile time error. We can't use the unfreezable property because toFreeze might not exist. But now we need to fix a compile time error. So we need a way for the compiler to decipher the unknown value. One way we can do this is to use a type guard. A type guard is a special kind of function that gives TypeScript hints about how to narrow a type. In other words, it tells TypeScript how to go from a broad type, like any or unknown, to a specific type. A type guard is a runtime check that maps to a type. It takes an input of unknown and checks that the input is a type by looking up the property on it. We use a special is keyword to define what that type is when it's finished. Our type is defined as an object with a property of unfreezable set to true. So after we've called the type guard, TypeScript knows that within the if statement, our object is definitely not unfreezable. But right now, the implementation is a little bit weird. We're talking about something being not unfreezable, and we're doing all of our work inside of the if statement with a weird throw outside. It would be way better if we could talk about something being freezable. And TypeScript has another handy type to help. Let's go back to our Venn diagram once again. Inside, we have our two top types, any and unknown. All values are valid for these types. But outside of any and unknown, we have another type, which is called never. The never type is the bottom type of the type system. It is a type which has no valid values. We can use the never type to describe what a freezable object is. An object with a value assigned to the unfreezable property can never be assigned to freezable. This means that we can invert our type guard. We can rewrite it in terms of being freezable. Instead of as unfreezable and checking for the presence of unfreezable, we write it as freezable and check that there's not an unfreezable property. This means that we have no more double negative. but we've still got the weird control flow. A way that we can get around this is use never again. Another way to use never is for a return type of a function that never returns. For example, a function that throws an error will never return a value, which we could use like this. To get even better, we have the idea of an assertion guard, which combines type guards and never. If a function doesn't throw, the return type is freezable. And here we are saying that we assert that a thing is freezable. So if it does throw, it returns never, but if it doesn't, we know that we're freezable. Any code that executes after the function call, therefore, must be running on a freezable type, which means we can have much more sensible control flow. That's looking great, said Elsa, but we can still go further. Our input is still typed as unknown, so we're still depending on a runtime error. But now that we've got our freezable type, we can restrict our input to only accept things that are freezable. Now we have a runtime and compile time safety checks. Chapter 4, to be frozen. Sven and Olaf were delighted. What's next, we asked. Next, we need to talk about what is involved with freezing something. I use a very obscure dialect of TypeScript for my ice magic, said Elsa. It looks something like this. You're just going to have to trust me that it works. We can simplify it down a bit to understand what's going on. The function tries to run the magic on the object, and then it sets the frozen property of that object. But now we have some messy types again, and we need to fix them. We already have a freezable type, but we need to somehow replace the unknowns and the any. We need to have a frozen type. The most basic version of this might look something like this basic frozen type, where the property frozen is set to true. But it doesn't really express what we mean. We want to combine the type of our freezable thing and augment it with the basic frozen type. So we need a type that describes something that is freezable, but also has the frozen property. We can use TypeScript to express this by using generic types and intersection types. Here, we say that if an object is a frozen of some type T, it has all the properties from T and all the properties from this extra object, in our case, the frozen true. Let's dive in deeper. It can be useful to think about complex types in equivalent JavaScript syntax. You can think of a type as like a function. Adding a generic type parameter is like adding a parameter to that function. An intersection type is kind of like a type version of an object spread, where you get all of the properties from both types. Using this, we can almost correctly express our function. We can replace all of our any's and unknowns with frozen of T. But there's still one thing missing. Do you see what it is? It doesn't say anywhere that the input has to be freezable, offered Olaf. Exactly. For that, we need to express one more type relationship. We have our freezable type, and we want to describe all types that contain freezable. Just like any was a supertype of Boolean and string and array, we want a supertype of freezable. For that, we can use the extends keyword. If we go back to our function analogy, using extends is a bit like specifying a type with a type parameter. Anything that enters that type parameter must be of that type. We can even set a default for the type parameter. In this case, we set it to freezable by default. So now we just need to have everything that we need to use the freeze function. So putting it all together, we have a freezable type, which is an object with the unfreezable property that's never assignable to freezable. A frozen type, so a frozen object is the intersection of a freezable object and an object with a frozen property set to true. The assert freezable function, which is an assertion guard that takes an object input and throws an error if the object is not freezable. And we have a freeze function. The function, which is a function that takes a freezable input, asserts that it is freezable, freezes the object, and then returns a frozen type. Olaf was very excited. The library's finished, he asked. Come on, Sven, let's go show Christoph right away. And before Anna and Elsa could even try to stop them, Sven and Olaf were out the door and on their way. Chapter 5. Too fast, too frozen. Olaf and Sven rushed to show Christoph their library. Hi, Christoph. We made you a library to help make your job easier. Snorted Sven. You can use it to freeze anything you like, just like Elsa. And it will even stop you from freezing anything that can't be frozen. Christoph was blown away by this. You made this for me? Let's try it on me right now, suggested Olaf. Christoph is quite the rockstar developer, so he wrote a little script very quickly. But just as he ran the script, Anna and Elsa burst in. Wait, stop, exclaimed Elsa. We still need to write the Thaw function, said Anna. But it was too late. The library worked. Olaf was frozen. Chapter 6. Do you want to thaw a snowman? Christoph was devastated. Oh no, what have I done? I've frozen Olaf. We need to move fast, said Elsa, or Olaf could be frozen forever. Let's start with the JavaScript. We have a thaw function which will delete the frozen property of an object, and we will use the assert frozen function to validate the input. Can't we just add any everywhere and fix it? Asked Christoph. It's too risky, replied Anna. We don't want something going wrong. Sven, why don't you add types to the assertion guard first? Gulp, Sven. First, Sven added the unknown type to the input. Then he cast the input to frozen to do the check. And finally, he added the assertion statement for the return type to validate that something is frozen. That's perfect, said Anna. Clip clop, said Sven. Now we need to add types to the thaw function. Christoph, I'll need your help, said Anna. So we can start by adding a generic type for the input that has to extend frozen. But I have no idea how to do the return type. Please help. We need to use TypeScript to extract the type of the original object from the frozen type. This is the perfect time to use conditional types. Conditional types let us change type based on the state of other types. We have a condition, a type for if the condition passes, and a type for if the condition fails. A conditional type is kind of like a type function with an if statement. Different types are returned based on the state of the condition. Conditional types also have an extra special power, which is called type inference. Type inference gives us a mechanism to extract types from other types. Imagine that we want to extract the type of the return value of a function. We can write a conditional type called return type, which takes in a type parameter t. We check if t is a function with some number of parameters and then return a type, and it returns a type r. Then we infer r using the infer keyword. If the condition passes, t is a function, and so we return r. Otherwise, t isn't a function, so we return never. If we pass at the type of a function, we get back the return type. We can do the same thing to figure out the parameters of a function, the types of the parameters of a function. We check if t is a function with a number of parameters p, and then we infer p using the infer keyword. If the condition passes, t is a function, so we return p. Otherwise, t isn't a function, so we return never. Again, if we pass at the type of a function, we get back a list of the types of the parameters to that function. we can use type inference to extract the type of the generic frozen object. We check if t extends frozen with some generic type r, and we infer r using the infer keyword. If the condition passes, we use r, otherwise t isn't frozen, so we return never. If we pass it a frozen object, we get back the type of the original object. Okay, said Christoph, I've got this. I'll update the Thaw function. We'll add the thawed conditional type, use thawed as the return type, and cast the result. That looks perfect to me. Let's save Olaf before it's too late. Chapter 7. That was weird. Christoph, Sven, Anna, and Elsa worked together to quickly write a new script. Thanks to the library's excellent types, they were confident that the code was good. So they ran the script, and just like that, Olaf was back to his normal self. Hi everyone, my name's Olaf. That was weird. What happened? Oh, Olaf, we're so glad you're okay. So much has happened. Christoph, I think you'd better explain. Okay, I think we've got it. Are you ready, Sven? Sniff. Sniff to Sven. Unknown is better than any. Sven, don't you think that's true? Yes, unknown's too flexible. Unknown's your new bestie, and never is pretty cool too. Generics are also quite useful for describing unknown types. And don't forget unions, conditionals, and inference. Your users will have a great time. That's right. Good types are worth the hype. And just like that, everything was back to normal. The end. Thanks everyone. I hope you enjoyed that. You can find me on the internet. Again, tweet me any questions you've got, and all my slides are online here. Thanks so much.